All right, guys, welcome to this page of the notes. Again, we're working our way through composite functions. And what I'm going to do in this example problem, or in these example problems, is we're going to look at tables when the information is given to you in table format. Please notice I've given you two tables, Table 5 and Table 6. And the information listed on both tables is different. Table 5 has the functions f of x and g of x. Table 6 has the functions h of x and k of x. So you want to be really careful as we work our way through the example problems. Some of them will be f of x, some of them will be h and g, some of them will be h and k. Please make sure that you use the proper table when doing these. And here we go. Let's go ahead and take a look at the very first one. We recognize this sort of notation, but since this is our first one we're working together through, let me go ahead and rewrite that. This f of g of negative 7 you should recognize as f of g of negative 7. So here's what we got. We have f and g, which means I'm going to be using table 5 because table 5 has f and g in it, right? It's f and g. You don't want to use h's and k's. I didn't ask you about the functions h and k. I asked you about the functions f and g. Please use table 5. Now remember the way that this works. My domain value, the x value, is a negative 7. So I'm going to plug a negative 7 into g, get some result. I'll then plug that result into f, and f will give me back my final answer. So here we go. I plug a negative 7 into g, an x value of negative 7. Well, here's my x values right here in this first column, and I need to find negative 7, which is right here. There's negative 7. Now, I need to figure out when I plug negative 7 into g, what do I get back? Well, I plug the x value of negative 7 into the function, there it is, g of x. So when you plug in a negative 7, g of x is equal to a 4. So g of negative 7, that thing is equal to 4. Well, now what we do is we take that value and plug it into f. So 4 is my new domain value. That's my new x. So I need to find that new value of x. Here's my x's. I need to find my new domain value, which is 4. There it is right there. So I'm going to come down here to 4, right? And now I'm going to plug that 4 into the function f and see what I get out. Well, I plug a 4 into, there's f of x. So I plug a 4 into f of x, and what do I get out? It looks like my table tells me I get out a 3. So my final answer is going to be 3. Again, works the exact same way as it did with relations, works the exact same way as it did with the graphs. It's just now instead I give you a table. You just work your way through the composite function, working your way through the table, and remember it is certainly possible to get undefined or does not exist. I started with a domain value of negative 7. I plugged that into the function g first, which gave me back a 4. I then need to plug that new domain value into f of x. So 4 is my new domain value right there. That's what I'm going to plug in. That's my new x that I'll plug into f, which gives me back my final range value of 3. Let's go ahead and do one more of these where I write it all out for you, and then we'll see how you do on your own. We're going to do f of g of 0. Let me erase this stuff because we're doing a different one. And here we go. I need to start with 0. My x value is 0. There it is right there. I'm going to plug that 0 into g first. So I need to go all the way over to g. Looks like it's going to give me a negative 2. So now I have f of minus 2. So now I'm going to plug minus 2 into the function f. This is my new domain value. So I need to find that domain value. I need to find that value of x. There it is right there. So we just bring this guy back. There's my new domain value right there. and I take negative 2 and plug it into f, which gives me a 9. Again, start with your domain value, go to whichever function they tell you to go to first. 0 of g, I'm plugging 0 into g. Plug 0 into g, I get negative 2. That's where the negative 2 comes from. Now I'm going to plug that negative 2 into f. So I need to find that domain value. There it is, right? That x equals negative 2. Plug that into f, and f gives me back a 9. All right, guys, we've worked through it twice, kind of drawing the arrows and the circles. Please feel free to use those if it helps you here for the next couple of times, just until you get used to it. But I think we should be able to work our way through these next ones here a little bit quicker. So let's see how this goes. The next one, oh, sorry, I'm drawing all over that place. Okay, the next one we're going to do is f of g of 4. Remember the way this works, I'm not going to rewrite it. 4 goes into g, and then we plug that result into f. So here we go. I find my 4. There it is. I go to g. I get 6. 6 is what I'm going to plug into f. So I need to find 6 in my domain column. There it is. Take that to f minus 10. Let's do the next one. Ooh, look at this. The next ones are going to be h and k. So I'm now switching tables. Don't use table 5 anymore. That has f and g in it. I now need the functions h and k, so you're now going to use table number 6. All right, so I'm going to switch tables. And I'm going to start with a domain value of negative 15. That's going to get plugged into k. That result gets plugged into h. So we start with negative 15, go to k, then take that and go to h. So let's see how this works. Negative 15. There it is. I plugged 15 into k first, right? Because it was k, or h of k of negative 15. So k goes first. Negative 15 goes into k. I get out a 5. I need to find that. That 5 is my new domain value. So we look for 5. There it is. There's my 5. Plug that into h. I get out a negative 150. So this guy, negative 150. Do the next one. H of k of a negative 10. So negative 10 is going to go into k. That is then going to go into h. Let's slide on up here and see what we've got. My domain value, my x value is a negative 10. So I start with negative 10 and I go to k first. Negative 10, go into k. It's a 15. I'm going to plug that. That's my new domain value. So I need to find 15. There it is. There's my 15. And that now goes to h, which is a minus 90. So this guy's going to be equal to a minus 90. And I got one more to do. Again, I'm going to be doing h of k of 15. So I'm going to start with the 15, plug that into k, take that result, and then plug it into h. So we start with 15. Let's see here. Oh, sorry, hang on. We've got to be able to see h and k. There we go. There's 15. That's my domain value of 15. I go to k first. So 15 gets plugged into k. K tells me I get back a negative 10. All right, that's my new domain value. So I need to find negative 10. Come down through. There's negative 10, my new domain value. I'm now going to plug that into h, which tells me I get back minus 300. All right, guys, here's what we've looked at so far. You have looked at doing composite functions of relations, composite functions of graphs, and composite functions of a table. In the next couple pages of the notes, we're going to look at actually doing composite functions when I actually give you what you think of when you think of a function where you have f of x is equal to some polynomial and g of x is equal to some polynomial. So much more typical looking functions. And we'll look at how you find the composites when you're actually given a function. But guys, by far, the relations, the graphs, and this one with the tables, I really, really like these types of problems. If you're taking this class with me, you're going to see these on both quizzes and tests where I give you a relation, or I give you a graph, or I give you a table and ask you to find the composite functions. I really like these example problems a lot. I really think it goes a long way to showing how well you understand composite functions, plugging domain values into, which function does it get plugged into first, and then taking that and plugging it into the second function, right? It goes a long way to showing your depth of understanding of how these composite functions work. Anyway, head on over to the next page of the notes. We'll take a look at the more typical algebraic composite functions. I'll meet you guys over there.